Okay. All right. So in 8.2, we learned we learned what a matrix was, and we learned how to solve a system of equations using row operations. So I gave you the 3 basic rules for that game where we try and get 1s down the diagonals, 0 everywhere else. That's called the reduced row echelon form. If you wanted to get it in row echelon form, 1s down the diagonals, 0s on that bottom little triangle there, and then figure out what z was, plug it in and find out what y is, plug those in, find out what x is. You can do that, okay? That's the minimum that's required on the quiz, okay? That's one way you can use matrices to solve a system of equations. We're going to talk about a couple of other ways that you can solve a system of equations, and we're going to do something called Cramer's rule today, if we can get to that point. If nothing else, we're going to cover how to solve or how to find determinants of a matrix, okay? So we're going to start with that vocabulary there, the determinant. And I've got a little definition right here. It says a determinant is a unique number, it's just a plain old number, associated with each square matrix. It's a unique number associated with each square matrix that contains information about the numbers in the matrix and the position that they were in. Okay? So I've got a determinant written right here, and I've got a matrix written right here. Does anybody notice the difference between the two? Straight lines versus square brackets. This kind of looks like absolute value. It's not. It's just the notation we use to indicate that we want to find the determinant of that matrix. Okay? So that right there is a matrix. This, once you know how to do it, it turns into just a plain old number that we call the determinant. And that determinant is one unique number that tells us about what these numbers were in here, the 3, the 1, the 4, and the 2, and where they were, because where they were makes a difference as to what it is. Okay? So has anybody seen determinants before? One of you? Okay. So a determinant on a 2x2 is really easy to find. Okay? On a 3x3, it's a tad more difficult. Okay? So if you've got a determinant of a 2x2, so let's say the entries are A, B, C, and D. So the first row is A and B, and the second row is C and D. The determinant of a 2x2 is just A times D minus B times C. Or if you look at it this way, it's actually just multiplying the diagonals here. So that's A times D, multiplying the diagonals here. That's B times C. And then you subtract the diagonal that went up from the diagonal that went down. So that's where we get the A times D minus the B times C. So I've got a couple simple examples right here. There's the one that we had up above. So this is a determinant. If you see it in what look like those straight bars, kind of look like absolute value bars, it means go ahead and find the determinant. So the determinant of this 2x2 is going to be, I multiply those together, I get 6. Now do yourself a favor. Write the minus and then write down what we get when we multiply up here. What do we get? We get a 4. So the answer is 2. 2 is the determinant. That number 2, the fact that it's positive, the fact that it's 2, contains a bunch of information about what the numbers were in here and where they were. So let's take a look at this one. Again, we're going to multiply down, go down that diagonal. That's going to be negative 12. Again, do yourself a favor, write the minus, and then multiply up. What do I get? I get negative 3. So this is negative 12 minus minus 3, so that's going to be a plus of 3. So the answer there, the determinant is negative 9. Any questions? Okay, is this possible? It's not. Why not? Okay, not square. Not square. That means it's not possible. Okay? Doesn't have a determinant. Only square matrices have determinants. Okay? All right. Now, shortcut techniques. Again, most of what we're talking about here comes from a class that you could take in college called linear algebra. And you can take an entire course. In fact, you can probably get a degree in linear algebra. You could get a master's or a PhD. There's a ton of information in linear algebra. Okay? But in order to know how to do a 3x3, we're going to introduce some terminology. Okay? So, that in the long run, I think is going to be a lot better off. Okay? So, each position in a matrix has a sign associated with it, okay? That sign has nothing to do with the number that's there. So it doesn't matter that there's a -3 here and a 3 there and a -2 there. It doesn't have anything to do with the number that's in that position. It has solely to do with just the position, okay? The sign is determined solely by the position. Just the position. Okay, the signs in a matrix are easy to remember because they're just in this checkerboard pattern. It starts with a plus here, and then a minus, and then a plus, and then a minus, and then a plus. The second row starts with a minus. So it's going to be minus, plus, and so forth. So you've just got this big checkerboard of pluses and minuses. All right? Now, if you're interested in why it happens to work out to be a checkerboard of pluses and minuses, I'd be happy to show you afterward. For the time being, just take my word for it. The position right here, 1, 1 position, first row, first column is positive. First row, second column is negative. First row, third column is positive. It just goes plus, minus, and so forth. This is the second row, first column. It starts out negative, and then plus, then minus, and so forth. So it's just a big checkerboard of pluses and minuses. Every position has a sign associated with it. Okay? With me there? Okay. So then we have to introduce a couple of other vocabulary terms. The first one is a minor. The minor is the determinant that's created when we cross out the row and the column of a particular entry. And a cofactor is the minor multiplied by the sign of that position for any particular entry. Okay? Now, it sounds like it's really awful. It actually turns out to be relatively simple. Okay? So once you understand these ideas, you're now ready to find the determinant of a 3x3 in a technique called expansion by minors, or it's also called cofactor expansion. Sounds really horrible. It's not. Okay, so this is a 3x3 determinant. Notice that it's not a matrix anymore because it's got these straight bars on the side. So we want to find the determinant. So we need to find the minors and the cofactors. Usually we'll just skip straight to cofactors, okay, but we'll kind of break it up a little bit. So let's figure out what the minor is for 1, for 2, and for -3. So I'm looking at this 1 right here. There's only one positive 1 in here. So the minor is the determinant that we get when we cross out the row and the column for a particular entry. So if I'm interested in finding the minor for 1, I cross out this row and I cross out this column. So what's left? A little 2x2 matrix, so it's the determinant that's left. Whoops, 3, -1, 5, 6. That's the minor that's left. Let's do it for 2. Let's find the minor for 2. Cross out the row and the column. What's left? -2 and -1. And 4 and 6. Okay, would you write down the minor for -3? Cross out the row and the column, so this would be -2 and 3 and 4 and 5. Okay, are there any questions there? Does everybody understand how to find a minor of a 3x3? Okay, watch. Just to make sure you know how to find a minor. How about you find the minor of the element that's +3? So find where the +3 is. If you were going to do the minor, you don't have to write this down, but just think about it. You'd cross out the row and the column. Cross out the row and the column. So what would its minor be? 1, -3, 4, and 6. Everybody with me there? Okay. This is a fairly advanced topic. I mean, finding minors and cofactor expansion and stuff like that. They do this in a class that's after calculus. Okay. But that's not too bad, right? Okay, now, we just found the minors and we wrote them this way, but they're actually a number. They're actually a determinant. So this determinant is, watch, 18, right, minus 5. So what is it? 23, okay? So this stuff that we wrote here is kind of like the work to get the minor. So the work is this little 2 by 2 determinant. The actual minor is the number 23, okay? Let's do this one. So this is going to be negative 12. I'm going to write the minus, and then I get negative 4. So the actual minor is negative 8. And on this one, I've got negative 10. Write the minus. That's going to be a 12, so I get negative 22. There's the minor. Okay, are there any questions there? Okay, I'm going to change colors, so now we want to find the cofactor. So let's go back up here to the vocabulary. A cofactor is the minor multiplied by the sign associated with that position. It's the minor multiplied by the sign associated with that position. So where is the 1? Okay, the 1 is in that first row, first column. The sign associated with that is positive. So if we were to write the work, I'm going to write a plus. The minor would be 3, negative 1, 5, 6. What number would that work out to be? It would work out to be 23. Find the 2. What's the sign associated with that position? Negative. Its minor is the determinant of negative 2, negative 1, 4, 6. We already figured out that was negative 8, so what does it turn into? Positive 8. And for the negative 3, what's the sign associated with that position? Positive. Negative 2, 3, 4, 5. Negative 22. Okay? Now, here's how easy it is. So